Hey there. So, if you've ever spent any time coding, you've totally been there, right? You find yourself typing the exact same lines of code over and over and over again. It's just messy and it's practically begging for you to make a mistake. But what if there's a way, a much smarter way, to handle all that repetition? Well, there is. Let's get into it.
Just look at this. The difference is night and day. On the left, that's the old way, this big, clunky, repetitive mess of code doing the same calculation again and again. But on the right, that's the smart way. It's one clean, elegant, totally reusable block of code. That, my friends, is a function. And that's the power we're going to talk about today.
So, what exactly is this magic we're talking about? Well, a function is basically a self-contained block of code that's built to do one specific job. The best way to think about it is like a recipe. You write down the recipe for a chocolate cake once. Then, anytime you want a cake, you just pull out the recipe and follow it. You don't have to reinvent how to bake a cake from scratch every single time. And every one of these recipes, every function, has the same basic anatomy. It's super simple. First, you start with the keyword def. That just tells Python, hey, I'm defining a function. Then you give it a unique name. After that, you've got parentheses. Think of these as the spot where you'll list your ingredients. And finally, a colon, and then an indented block of code where you write the actual instructions. That's it.
Okay, so this brings up a pretty important question. A recipe is kind of useless if you can't put ingredients in and get a finished dish out, right? So how do we actually pass information to our function, and how do we get a result back?
The answer comes down to two words you've got to know: parameters and arguments. So parameters, that's what you see on the left. They're the placeholders inside your function's definition. In our recipe, this is the ingredient list, like flour or sugar. Now, arguments, over on the right, those are the actual values you hand over when you use the function. That's not just sugar, it's 1 cup of sugar. Parameters are the placeholders, arguments are the real deal.
To really nail this down, think of it like this. Parameters are just the names you see when you're defining the function. Arguments are the actual values you use when you're calling the function. Getting that difference is totally key to making functions work for you.
So how does Python know which argument goes with which parameter? Well, the default way is just by its position. The first argument you type, John, gets handed to the first parameter. The second argument, 25, goes to the second parameter. It's simple, it's direct, but you have to remember, the order is absolutely critical. But, what if you don't want to worry about the order, or you can't remember it? That is where keyword arguments are a lifesaver. Here, we're explicitly telling Python which value goes where by using the parameter's name, like age equals 25 and name equals John. Suddenly, the order doesn't matter at all. It gives you so much more flexibility. Okay, we've put our ingredients in, the recipe has worked its magic, but how do we get the finished cake out of the kitchen? For that, we use the return keyword. This little statement basically tells the function, all right, your job is done. Send this value back to whatever part of the code called you. It's how our function delivers the goods. All right, you've got the basics. Now let's level up with a pro tip that will seriously save you from some major headaches down the road. We need to talk about something called variable scope. It's all about where your variables are allowed to exist. Think of it like this. A variable like p here, which is defined outside of any function, has global scope. It's public. Everybody in your code can see it and use it. But a variable like q that's created inside a function has local scope. It's private. It only exists inside that function and nowhere else. And here is exactly why that matters. If you try to access that private local variable q from outside its function, Python is going to slam the door in your face with a name error. It's a fundamental rule of the road. What happens in the function stays in the function. Unless, of course, you use return to send it out. You ready for a little bit of a mind bender? Let's take a quick look at something called recursion. Now, this is a really elegant, really powerful idea, where a function actually calls itself to solve a problem. It sounds a little weird, I know, but it's an incredibly cool technique. So at its core, recursion is just a way to solve a big problem by breaking it down into smaller, identical versions of the same problem. Instead of using a loop, the function just keeps calling itself, getting one step closer to a really simple final answer with each and every call. A classic problem that's perfect for recursion is calculating a factorial. The factorial of 5, which you write as 5 with an exclamation point, is just 5 times 4 times 3 times 2 times 1. Let's watch how a recursive function would chew through this problem.
So the function starts with the number 5. It knows that to solve for factorial 5, it first needs to know the answer to factorial 4. So what does it do? It calls itself, but this time with the number 4, and it puts its current job on pause.
Now that new call, which is working on the number 4, realizes it needs the answer for factorial 3, so, you guessed it, it calls itself again.
You can totally see the pattern here, can't you? It's like stacking up a set of Russian dolls. Each call creates a new, paused version of the same function, all just waiting in line for the one below it to finish its task.
This chain reaction just keeps going, stepping down from 3 to 2.
And finally, it gets down to 1. Now, this is the most important part of the whole process. The function hits what we call a base case. It knows a factorial of 1 is just 1. It doesn't need to call itself anymore. This is the stop sign that prevents an infinite loop. The dominoes are all lined up, and now they're ready to fall backwards.
That last function returns 1 to the function waiting for it, the 2 function. That one calculates 2 times 1 and passes the result up to 3. That one calculates 3 times 2 and passes it up, all the way back up the chain until that very first call gets its final answer, 120. Pretty cool, right? That's recursion.
So let's wrap this up with the big takeaways. First, functions are your absolute best friend for turning repetitive code into powerful, reusable tools. Second, always remember, parameters are the placeholders in the recipe and arguments are the real ingredients you put in. Return is how you get your final dish, and scope is just the rulebook for where your variables are allowed to play.
And that really just leaves us with one final thought to chew on. We've seen how a single function is like one recipe, but the real magic, the real power of programming happens when you start combining them. If you have a function to chop vegetables, and another to boil water, and another to sauté, what incredible complex program, what amazing meal could you create? That right there is the heart of building software.